taking a look at batteries. Batteries are also known as an electrochemical cell. The chemical reaction in a cell releases free electrons. These electrons travel from the negative terminal of the cell, which is referred to as the anode, through the device, which uses electricity, like a circuit, and back to the positive terminal of the cell, the cathode. The chemical reactions within the cell or battery determine the potential difference, aka voltage, that the cell can create. Different materials can create different voltages. Several cells connected in series produces a higher voltage and is commonly referred to as a battery, which is a sealed case with only two terminals. So in the end, we get a sealed case with a positive and a negative. However, within the battery, there are multiple cells. Okay, so they can be made up of multiple cells, but in the end, we only see what looks like one. So again, the electrolyte is in a cell. The electrolyte is a substance that can conduct electricity, and it reacts with the electrodes, making one electrode positive and the other negative. So the reaction at the negative electrode, which we know is the anode, releases electrons. Electrons travel from the negative electrode to the positive electrode through a circuit. And atoms of the negative electrode become ions and go into the electrolyte solution. As a result, the negative electrode disintegrates. So over here we have a diagram of an electrochemical cell. We have one side, which is the anode, and the electrolyte is this solution here. Okay, and so there's an electrolyte solution on each side of our cell. Okay, they're different electrolyte solutions in this case. One of them is copper 2 sulfate and one is zinc sulfate. Okay, this is our anode. This is where electrons are made. So electrons are made when this electrode, an electrode is the solid piece here, breaks down over time. Electrons are made and they flow through the external circuit here towards the cathode because the cathode is positive and attracts those electrons to it. Batteries can be made with so many different things around your house. I've seen a potato battery. Obviously, a lemon battery is quite common. You could make this with almost any citrus fruit. So take a look at that video linked below in our course website if you're interested. A wet versus a dry cell battery. In a wet cell, the electrolyte is a liquid, usually an acid, or a solution, like we saw in our previous example. So, looking down here, we have a wet cell battery. This is a car battery, okay? These are sulfuric acid, or battery acid. The electrolyte is actually a liquid. Remember, electrodes are solid. So those are the positive and negative electrodes. Electrons are generated at the negative side, flow through the circuit to start our car, and back to the positive side. This is another example of what we just saw. We have a zinc and copper cell again. The electrolyte here is a solution. It's the copper sulfate liquid in the beaker and the zinc sulfate liquid in the beaker. In a dry cell, the electrolyte is a paste. So in this case, most batteries that we use in our small appliances are a dry cell. They contain a paste, so it isn't a full liquid of a bunch of different compounds to provide a chemical reaction. A primary cell is a battery that cannot be recharged. The reaction that takes place to generate voltage will not continue after the reactants are used up. It's the end. A secondary cell is a rechargeable battery. It uses a chemical reaction that can be reversed. It also uses an external electrical source to rejuvenate the cell by reversing the flow of electrons. So to reverse the reaction, we need to apply electricity, is what that's saying. Okay. The most common secondary cells are nickel oxide and nickel cadmium. The reactants are restored or rejuvenated, but the electrodes will eventually wear out over time. So remember, the electrodes are the solids. All right. And that's where the electrons are generated. So over time, a secondary cell will lose its ability to be recharged, but it does do a pretty good job for quite some time. Think about your phone or your computer. Over time, the battery is no longer as effective. Alessandro Volta is the guy who discovered a battery. So he created what he called a voltaic pile. So he had this stack of copper and zinc. And in between the copper and zinc, he placed an electrolyte. So he soaked a piece of cloth in a salt solution. Okay. So the copper and zinc discs were separated by cardboard or cloth spacers that were soaked in water. Each set of copper and zinc and this electrolyte was able to produce electricity. However, what he did is he stacked them on top of one another. So each set of copper, zinc, and electrolyte is one cell. He called it one element here, but one cell. All right. And together, because we have multiple cells here, you can see there's a bunch. Together, they make a battery. This was his original voltaic pile. You can see here that this is where we would connect one piece. Based on this diagram, this would have been the negative electrode, and down here, this would have been the positive electrode, just based on this diagram here. Okay, and this generated a voltage that could power something. If you remember, way back in chemistry, we talked about electrolysis. That was the splitting of water. This was able to be accomplished because of the voltaic pile. They created a source of electricity and used it to start splitting compounds into their atoms. A little video on how batteries work, again, linked below on our course website. The last thing we'll talk about are fuel cells. Fuel cells are a great alternative to batteries, and particularly a better alternative to a combustion engine. So these could be a replacement for cars. In a fuel cell, we combine oxygen and hydrogen to create electricity with no emissions. The best part about a fuel cell is that as long as we continue to provide oxygen and hydrogen, the cell will continue to run. So it isn't like a primary or secondary cell, which will run out over time. This cell will continue to generate electricity. It's also more efficient than a car engine. So what we can see is that if we add hydrogen gas to this anode, any H2 gas that isn't used is recycled and put back in. Oxygen from the air is pushed into the other side of the cell, and the emissions are air and water vapor. So oxygen and water vapor, which isn't as toxic, of course, and harmful to our atmosphere as CO2 and some of the other byproducts of combustion. This is a GIF, and I've linked it on our course website so you could take a look at how this works. There's some practice for this chapter in your learning guide, for topic 5. There's also some extra practice at the end of topic 5 in your textbook.